How's it going, friends? Here we go. We're going to go through the 2-1 notes. Those are over parallel lines, transversals, and angle pairs. So first off, parallel lines, we've probably seen this before in algebra, but just as a reminder, parallel lines are two coplanar lines that never intersect, just like these that you see on the right. We would notate two parallel lines by saying that line AB in this situation is parallel. So that's our symbol for parallel. Just those two kind of up and down lines there are parallel to line CD. So sure enough, if you look here, AB, CD, they are parallel. How else do we know that they're parallel? Well, you'll notice these two little triangles on those lines. That's going to indicate that they are parallel as well. So two little arrows indicate parallel lines. So something else worth notating. Okay, so parallel lines, two lines that do not intersect. And if you have parallel lines, now that we're in geometry and you know that planes exist, we can have parallel planes as well. I can say that plane J is parallel, there's that parallel symbol again, to plane K. All right, so planes can be parallel as well. And then finally, parallel lines never intersect. Parallel planes or planes that never intersect. There's actually another type of line that never intersects, and they would be skew lines. Skew lines kind of go in different directions on different planes. So non-coplanar lines that never intersect. So for example, if I looked at TW and I looked at UQ, and I pretended that those lines went infinitely onward, they do not actually exist on the same plane. However, they also do not intersect. So if you try to visualize this as like an actual three-dimensional object, it's like a line across the ceiling and then a line in the opposite corner. Those are both extending infinitely, but never crossing. So while they're not going the exact same direction, like TW and UV, those are parallel. Those are going in the same direction. They're on the same plane, right? They're both shared on this kind of top plane. These are not. They're going in kind of opposite directions, different directions, but also never intersecting. So this is an example of a skew line. Other examples of skew lines, I could do, let's say, SP and VR. Those would be examples of skew lines as well. You could see that, let's get a different color here. You could see that SP, in a similar fashion to the ones that we were just looking at, and VR, never intersect. Some other examples, and I guess I could do this across any corner in any sort of opposite part on the top or the bottom would work. And I'll tell you what, TW and VR are also skew. And SP and UQ, I believe that's a Q, yeah, are also skew. So I actually have several examples of skew lines here. They're lines that are going in different directions on different planes and never actually crossing. All right, what else? Segments, here we go. So now let's take a look at some pictures here, and we're gonna work through the some examples that you might see on, say, like a quiz or a homework or something like that. So for example, name all segments parallel to AE. So what I'm gonna do is I'm gonna mark where AE is, and I'm gonna try to find parallel segments to that. Now, there's some that are sort of obvious. HD is an example. HD, it's a segment, so we're gonna put a line with no arrows on that. FB, also pretty obvious. We know that these segments are parallel because like they're on the same plane. I've got A, E, and an F, this like front of the box here. So both sides on this front of the box, both sides on the kind of like left side of the box. And there's actually another segment that's parallel, and that's GC way over here. If you imagined sort of a like slicing this box in half, pretend it's like a cake or something, and you sliced from corner to corner, you would actually create this like new plane in the middle, right? And AE and GC are either sides of that plane. So that is those are definitively all the segments that are parallel to AE. So now let's talk about parallel planes. All right, 2 examples of parallel planes. Well, these are just going to be planes that never intersect. So if thinking of this as a box, I could use the top of the box and the bottom of the box. Top and the bottom are never going to intersect. Now remember, you use 3 letters to signify a plane. So we could say the top is E, H, G, and the bottom can be A, B, C. So you need 3 points that are on that plane. So I could have gone A, B, D, B, C, D, any combination of 3 letters on the bottom, any combination of 3 letters on the top. F, G, H would have worked. But yeah, so there you go. There's an example of parallel planes. I could also say that, say, like the right side of the box and the left side of the box. Those are also parallel to each other. So I could say E, H, D this time. So EHG took me across the top, whereas EHD takes me across the side. It deals with the side. And FGH, or sorry, not FGH, FGC would work as well. All right. Now all segments skew to GH. So I'm going to erase all this stuff because it's getting a little crowded. Let's find GH. GH is back here. We're going to try to find skew segments to GH. Now remember, they are on different planes. So you might say, hey, GH is never going to intersect with DC, right? Well, true, but they're parallel because they're both on that kind of like back of the box. They're on the same plane. And same with EF. Those are never going to intersect, but they're parallel. They're not skew. They're on the same top plane as HG. So which ones are actually the skew lines? That is going to be ones like FB. FB is on a separate plane. It's going up and down. HG is going left and right. But because they're on different planes, they're never going to intersect. So FB is an example of a line, a segment that is skew to HG. All right, that would probably lead us to conclude that AE or EA is also a skew segment. We got some others down here. BC. BC is going front and back while HG is going left and right. They're never going to intersect. Those are skew as well. So you see how you kind of want to make sure that different lines are, you really are all encompassing, making sure you're not skipping anything here. And then there's A, D as well. So we have, it looks like 4 segments. If I went through all these other ones, HD obviously intersects at H, GC intersects at G, FG intersects, EH intersects. This one's parallel. This one's parallel. The only other one that we have would be AB, and AB is technically parallel as well for the same reason that we're earlier whenever we were identifying parallel lines. If I were to like slice this diagonally, I could create a plane that's sort of like a rectangle going diagonally through this box. So AB and HG, they're both going left and right. They're both going in the same direction, and we could create a plane in between there. So they are actually parallel. So I think those 4 lines that we indicated, FB, EA, BC, and AD, are the only ones that are skew to HG. Moving forward, we got segments that are parallel to JK. So we're going to identify JK, and I am pretty sure that the only segments here that are parallel are O and P. Like OP, that segment right there, that's it. JK, OP. Giving it a good look over before I say that's it, but I'm pretty sure that's it. Next up, a plane that is parallel to plane JKL. So if you're going to find JKL, what you want to do is identify where exactly those points are, J, K, and L, and then which face are all 3 of those points on. Those are on this, what would this be, a pentagonal prism. That face is like the front face. It's one of the pentagons. So which one is going to be parallel to that? Well, naturally, hopefully, you would identify that this back face would be parallel to the front face. And to name that one, all you need to do is pick 3 points on that face and just use those. So a plane parallel, we could say R, Q, P. For extra clarity, we could write the word plane in front of that. So plane RQP. And notice there's no line, there's no like double arrow up here or anything like that. It's just RQP. All right. 4 segments skew, so we don't have to name them all. We just need to name 4. 4 segments that are skew to RQ. So I'm going to find RQ right here. And we're going to just start naming skew segments. So let's see here. Feel pretty confident in saying that PQ, so those are never going to intersect. So we just need ones that are not parallel and don't intersect that actual line. So PK, feel pretty confident in that one. SN and OJ. OJ, SN, PK. Feel pretty confident that all those are skew. They're all kind of go in the same direction, but you'll notice that the other two go in that direction. MR and LQ, those are going to intersect RQ, aren't they? And let's just get one more that would be skew. A lot of these kind of lateral on the face lines would be skew as well. Like LK would be an adequate one to use here. So LK, also skew, but there's others. For example, JK is skew, NJ is skew, and I think that would actually round it out. This one's parallel. NM is skew, and everything over here is on the same plane, so we can't use any of those. These intersect, so this one's parallel, so everything else it would be considered skew. So plenty of lines to choose from, but there's 4 right there. Moving on. All right. So now lines and transversals. This part's going to be really important because we are going to be talking about lines and transversals, specifically with parallel lines, in the very near future. So learning this vocabulary is going to be critical to understanding what we're doing in the near future. So real quick, a transversal is a line that intersects 2 or more lines. So in this example, line T is our transversal because you can see that line crosses 2 lines. It crosses L and it crosses M. So your transversal is T, and the 2 lines being intersected would be L and M. Now let's talk about different types of angles. All right, again, very important vocab here. Corresponding angles. Corresponding angles are angles that are in the same position of the transversal and in the same they're same side of the transversal and same position. So you're going to have 2 intersections here. I have this intersection and this intersection. As I focus on these 2 intersections, you'll notice that 4 angles are created around each of those intersections, right? If you take like a space and you divide it with 2 lines, you're going to get 4 angles. The ones that are corresponding are the ones that are in the same position. So I could look at angle 1 here and angle 5 and say, hey, they're both in the upper left kind of quadrant of this intersection. So angle 1 and angle 5 would be considered corresponding. We use our little angle symbol and list them out like that. Angle 2 and angle 6 similarly are kind of in the upper right quadrant. And then, of course, we could just kind of go around now. Angle 7 and angle 3, or angle 3 and angle 7, if you want to go in a numerical order there. And then angle 4 and angle 8. Those are both in the lower left quadrant. Okay, so those are our corresponding angles. They're in the same position. So again, 1 is corresponding to 5 because from the intersection, they're kind of both up and to the right. 2 and 6 are both up and to the, those are up and to the left. 2 and 6 are up and to the right. 3 and 7 are down and to the right. 4 and 8 are down and to the left from the intersection. Okay, alternate interior angles. As we listen to some of these words, pay attention to the vocab. Interior, when you think of interior, you think of inside. And whenever you think of alternate, you think of opposite. So here's what's going to happen with alternate interior angles. Alternate interior angles are on opposite sides of the transversal, and they are inside those other 2 lines. So 3 and 5 are examples of alternate interior angles because they are both inside your 2 lines and on opposite sides of your 2 angles. So your alternate interior, your interior is like in here. This is your interior. It's inside those 2 lines. Your exterior, which we're going to get into in just a moment, is out here. So purple is interior, green is exterior. So let's talk about 2 more alternate interior angles. That would be 4 and 6. Angle 4 and angle 6. Those are both inside the 2 lines. They're in that purple area. Imagine like the L and the M, line L and line M, as fences. They're inside the fence, but they're on opposite sides of the transversal. All right, then you have alternate exterior angles. These are going to be, I'm gonna erase all this. This time we're gonna be on the outside. Alternate exterior angles, like 2 and 8, those are on opposite sides of the transversal. One's on the right side of the transversal, one's on the left side of the transversal. But you'll notice that they're both exterior to the two lines. So angle 2 and angle 8 would be example of alternate exterior. And then, of course, angle 1 and angle 7 are also examples of alternate exterior angles. You can see one outside and on the left, and 7 is outside and on the right. So they are alternate, as in they're on different sides of the transversal, and exterior is in they are outside those two lines. Let's talk about consecutive interior angles. Consecutive interior angles, consecutive now, think of those as being like next to each other. So once again, we're talking about the interior here. The interior of these two lines is kind of this space in here. It's inside the fence created by the lines. Now that we're talking about consecutive, if alternate meant that they were on opposite sides of the transversal, consecutive is going to mean that they are on the same side of the transversal. So for example, angle 3 and angle 6 are both on the same side of the transversal and they are interior. Angle 4 and angle 5 would be another example of this. Angle 4, angle 5 as being both interior and on the same side of the transversal. All right, as you could probably guess, consecutive exterior angles. We are back to being focused on the exterior of these lines. So out here, outside the fence, and your consecutive angles are going to be on the same side of the transversal. So 2 and 7 are both outside of L and M. They are in the exterior, but they are on the same side. They're both on the right side of the transversal. So angle 2 and angle 7 would be an example of consecutive exterior angles. And angle 1 and angle 8, both of them on the left side of the transversal, would be considered consecutive exterior angles as well. And then the rest of this is just going to be like, all right, what are these angles? So I'm going to basically be going through, highlighting angles and trying to figure out what they are. We actually have lots of transversals and lines. So whenever we pick these out, there's going to be moments where it's like, hold on, which one's the transversal, which one's the line? And we'll kind of work through that as we get there. So first off, 5 and 13. It's kind of important to note where the intersections are whenever you're dealing with 5 and 13. That's dealing with this intersection and this intersection. So this intersection of C and B and the intersection, so C and B, and the intersection of D and B. So what is the shared line in that relationship? Well, B is the line that goes through both of those. So that's your transversal. And then the other two lines are just the two lines that are being crossed by the transversal. So now that I kind of have my bearings about me, my interior is inside here, my exterior is out here where like 5 and 6 are and 15 and 16 are. So now the question is, well, what is the relationship between 5 and 13? And what I see here is that they're both on the same side of the transversal and they're both in the same position. So they're both on the left and they're both up from that intersection, both in the upper left. That's going to make them what are known as corresponding angles. All right, 7 and 14. Here's 7, here's 14. Same transversal, same line. I didn't need to erase what I just did, but here's your transversal, here's your two lines. These are both inside those two lines, and they are on opposite sides of the transversal. So whenever I think about opposite, I'm thinking alternate. When I'm thinking about inside, I'm thinking interior. So these are alternate interior angles. Then I've got 3 and 6. All right, this is the first time that the transversal and the lines are getting changed. So let's get that stuff out of there. Now I'm looking at, here's 6, here's 3, Now look at what intersections we're dealing with. We're dealing with these two intersections. They're shared by C, and your lines are B and A. So now you can maybe turn your paper sideways, but you need to visualize that now your lines are running up and down and your transversals moving left and right. 3 and 6 are alternate exterior angles. The interior between these two lines, A and B, is in here, 2, 4, 5, 7. The exterior is 1 and 3 and 7 and 8. These are on opposite sides of our transversal, so that means alternate. These are outside the line, so that's exterior. Alternate exterior angles. Moving on, we're going to move a little bit faster so we can wrap this up and y'all can get started on your homework. So I'm looking at 9 and 14. Both of those are outside of A and B, so still looking at A and B as being lines here. And then my transversals here, both of them on the same side of the transversal. So same side, outside, I'm thinking consecutive exterior. Four and 7. Back to A and B being my lines and C being my transversal. Both those are on the same side of C. They're interior between A and B, so that's going to be consecutive interior. Two and 10. 2 and 10. Those are corresponding. You'll notice that they're both up and to the right of their respective intersections. So they do share a transversal, right? So A is their transversal, C and D are their lines, and both of these you kind of go up and to the right, and that's what makes them corresponding. They're both in the same position and on the same side of the transversal. All right, 8 and 14. There's 8, there's 14. Those are consecutive interior. 6 and 11. Here we go. I had a feeling this was going to happen eventually. All right, so you'll notice with 6 and 11 that these intersections do not share a line. This is the intersection of C and B. This is the intersection of A and D. Because there's no shared intersection, that means that there's no relationship between these two angles. You can be like, they're both outside, but there's no transversal for them to be alternate on or consecutive on. So there is actually no relationship or none between 6 and 11. So none is an option. 4 and 13, check it out, it happens again. 4 is the intersection of A and C. 13 is on the intersection of B and D. A, C, B, D. They don't share any lines. There's no line that goes like this. So that is going to mean that there's none with that pair as well. And then finally, let's wrap it up with 4 and 9. Here's 4, here's 9. Look here, both of those are on the interior of C and D, and they are on opposite sides of line A. So that is going to be alternate interior angles. Well, I hope this video was as long as it was. I hope that it was helpful. I hope that you have enough information to go through and work through the homeworks. I'll be back soon and happy to answer any questions that you may have whenever I'm back. In the meanwhile, y'all have a great day, and I will see you next time in class.